Hi students. In this lecture, I am going to discuss problems based on equilibrium of rigid body. Let us see first one. Right, see the question given. The ladder shown in figure has negligible mass and rests on a frictionless floor. The crossbar connects two legs of the ladder at the middle. The angle between the two legs is 60 degree. The fat person sitting on the ladder has a mass of 80 kg. Find the contact force by the floor on each leg and the tension in the crossbar. Okay, see, this is the question given. So we have to calculate now contact force by the floor on each leg and tension in the crossbar. Let us see now how to start the problem. Right, first make the given diagram. So it is a ladder. So ladder is now like this. A person sitting at the top. There is a person, and given now this total angle is 60. That means a half will be 30. That is now 30, half angle. So here we have to calculate contact force by the floor on each leg and tension in the crossbar. And there is a thread now, you can just string between the two legs. So tension will be like this, T and T. Okay. And see here what else mentioned. There is no friction that it is simply given that given frictionless floor. So no friction. First of all, make diagram, free ball diagram. So here key point is that if you take now the ladder, it is in equilibrium. Ladder is in equilibrium. Okay. That means on the ladder, net force 0, net torque also 0. Okay. Let us focus on this left leg. Forces acting on that. Normal reaction upwards. And here also normal reaction upwards. Given frictionless, so no friction here. And next you can see weight of the ladder is, it is given negligible mass. Okay, so it has no mass. Then see what we can do here. First of all, we can write taking the person and ladder as system. In that case, weight of the person should be balanced by n plus n. So I'm writing first condition 2n should be equal to weight of the person, that is 80, that is mass of the person, into g. So we have taken now ladder and person as a system. In that case, weight of the person must be balanced by sum of these two. So from this n value, it is 40 into g, and g value 9.8, 40 into g. So it is now 392 Newton. Okay. So we got now normal reaction from ground on ladder. Okay. So now we have to find out tension. And if you want take, for example, horizontal as x-axis, vertically up as y-axis. So here we have taken net force along y-axis equal to 0. So from that we got 2n equal to 80 into g along vertical. If you want to take along x-axis net force 0, then see what happens. This tension is balanced by this tension. So it is of no use. Okay. So next one is, it is taking the torque equation. So net torque. So net torque should be 0. Okay. And since we are knowing that net force on the system is 0, net torque will be same about any point. Let us take now about the person, okay, torque equation. You can take either left leg or right leg, because in both the cases we get same answer. Suppose take now right leg. Then see what happens about the person. That means because of weight of the person, there is no torque. I'm drawing once again here. That is the right leg. This is now right leg. Force is acting on the right leg. Force is acting on right leg. Normal reaction upwards. Tension at midpoint, right? That is given midpoint. Tension T. So here weight of the person, we are taking about this point. So because of weight of person, no torque. About this point, because of a tension, torque will be clockwise. See carefully. About this point, because of tension, torque will be clockwise. And about this point, because of normal reaction, torque is anti-clockwise. Therefore, torque due to tension and due to normal reaction, both must have same magnitude and directions are opposite. Let us see now, due to tension, what is a torque? Tension T. You see distance how much? Your distance given now, it is 1 meter up to here, and remaining also 1 meter. So this distance is now T into 1, right? So we are taking force into perpendicular distance, that is equal to 1 meter. And how to know that? You just imagine a line passing through that point parallel to force. Then between these two lines separation is now 1 meter. Okay. So T into 1, that is equal to N into N value 392. N into, so this is now 30. This is 90. So this half also 30, right? 30. This is 90. Remaining how much? 60. Okay. See what's 30. This is now 90. Remaining is now 60. So now we have to focus. Let me take this as A. And this is now. So we want now AB length. Okay. This is an imagine a line like this. Okay. So we want now AB length. And AB length is, see how much? AB. Suppose this is C. So BC length equal to 2 meter BC length. If you take triangle ABC, it is now right angle triangle. So in that triangle, you can see if I'm taking angle 60, BC is now opposite side and we want AB, means adjacent side. Then take tan 60 is equal to tan 60 equal to BC value 2 upon AB. AB we want to calculate. That means AB value is now 2 by tan 60. That is now cot 60, right? That value 2 into Cot 60 means it is 1 by root 3. Cross check once. AB equal 2 by tan 60. Tan 60 means how much? It is root 3, right? So 2 by root 3. Now substitute here. It is now into 2 by root 3. That is now tension. So we got tension here. And from force equation, we got normal reaction. So net force equal to 0. Net torque also equal to 0. Okay. Let us see now next problem. And this is almost same kind of problem asked in 2005 for 4 marks. See once. Two identical ladders, each of mass m and length n, are resting on the rough horizontal surface as shown in the figure. A block of mass m hangs from P. You can see here where changes in the place of person. It is now a block of mass m is a hanging. In the previous question, a ladder was having no mass, right? In this case, ladder is having mass. That is now only change and remaining as it is. Okay. See calculation part. So make a diagram once. Again, same. It is making a ladder. And there is a weight here. Weight that is small mg. And coming to ladder, each of mass capital. So we can take that weight is passing through center of mass, capital mg. And here also capital mg. Okay. Next, at the contact. So at the contact, what we can do? In the previous question, it was given ground frictionless. It is now ground is a rough one. So we have to consider now friction. Friction, take it as F. And here also friction is now F. You just see carefully difference. Okay. In the previous question given no friction, but having tension, right? Connecting by a rope. Tension T, tension T. It is now F and F. Normal reaction N upwards. And here also normal reaction N upwards. Okay. Again, now same calculation. First thing, if you consider horizontal as x-axis, vertically up as y-axis, then writing first of all, net force along y-axis equal to 0. Okay. Then see what happens. 2n upwards, 2n equal to, that is equal to mg. It is now 2 capital M plus small m into g. And from this n equal to half of this, right? Next. Next, we want to calculate friction, right? Now, to calculate friction, let us take about this point torque. Suppose taking P, that is torque about to P equal to 0. So same calculation, okay, as it is, same as the previous one. Then see, I'm taking again the right leg, focusing on right leg, about this point. Torque will be because of normal reaction, because of a friction, and because of weight of the ladder. That is a capital M into G. Okay. Now see carefully about this point, because of normal reaction, torque will be anti-clockwise. See carefully once. About this point, because of normal reaction, torque is anti-clockwise. Because of mg, torque is about this point. If you apply force in this way, torque is now clockwise. Because of mg, torque clockwise. Because of friction, torque is clockwise. And because of normal reaction, torque is anti-clockwise. So you should be very careful while taking the direction of torque. About this point, if you apply force down, rod will rotate clockwise. If you apply force in this way, again rotates clockwise. If you apply force in this way, rotates anti-clockwise. So I am writing here torque due to gravity, torque due to frictional force, sum of these magnitudes equal to that of normal reaction. Now see, because of gravity, capital Mg into it is L by 2 cos theta. See carefully. It is now midpointed. So this is P2. So this is C, PC. PC is now L by 2. This is now given theta, right? So this separation equal to, it is L by 2, right? L by 2. Wait. I think I have taken diagram wrong, right? Angle is given with a horizontal. This is not theta. Given this is a theta, then this will be 90 minus theta. Okay. It is now mg into L by 2 cos theta plus, because of friction, it is F into, see what we get. It is F into L sine theta, right? F into, it is L sine theta, that is equal to normal reaction, that is N into, see this distance how much? That distance is equal to, that is equal to L cos theta. It is L cos theta. So main thing we have to focus while taking the perpendicular distance. You should be very careful. Okay. Next, remember just calculation. L gets cancelled. F equal to, or F sine theta equal to, F sine theta is equal to cos theta cos. This is a cos theta. Remaining is now N minus capital M G by cos by sin cot. It is a cot theta. N value, see how much N value? It is mg plus mg by 2. mg minus mg by 2. Remaining mg by 2, right? It is now remaining. So m plus m into g by 2. That is now frictional force. Okay. So previous question and this question both almost the same. Okay. With a slight difference. In the place of person, weight is hanging. In the place of a string, it is given now ground is rough. Okay. Right. Let us see next problem. A rectangular plate of mass capillum and dimensions A by B, means this length is A and this is B, is held in horizontal position by striking n small balls, each of mass small m, per unit area per second. The balls are striking in the shared half region of the plate. The collisions of the balls with the plate are elastic. What is V? So asked for 6 marks in 2006 and given N value, M, small m, B, A value and G. So we have to find V. So here key point is that this plate is held in equilibrium, right? With the help of these small balls which are striking that. So this is in equilibrium. So net force 0 and net torque is 0. Let us see. Right. First, make the diagram given. Given half part is shaded. So total length is given B and this is right. So here first of all what I am doing is I am taking now torque equation about this axis. Okay. Because a plate is not rotating. So plate is not rotating means we can take net torque must be 0. So I'm taking about this axis net torque equal to 0. See what we can say. So one torque is because of weight of the plate and we can assume the entire weight is acting at its center of mass. So it is now mg, that is weight. This total value is b, center of mass, distance b by 2. So it is now b by 2. So torque due to gravitational force. Okay, that is now mg into b by 2. This torque must be balanced by the force because of collisions. Okay, and that will be how say how much. Suppose F is a force because of collisions, not a force into. You can see those are making collisions only with this half part. So we can assume now that entire force acting at midpoint of this half part. See distance of this point from the axis. This is a b by 2. This is a b by 4. Total is now 3b by 4. Okay. So from here we can cancel b. And this is here 2 times, right? That implies f equal to, see how much f equal to 2 by 3 mg. Okay. Now focus how to get force because of collisions. Let us take it is given small m, mass of each ball, and it is given that collisions are elastic. So for each ball, velocity before and velocity after only changes direction but having same magnitude means speed is the same. So change in momentum, it is m into 2v. This is now change in momentum. And we are given n stands for number of collisions per unit area per second. And you can see this area equal to, if you multiply n with area, that is a into b by 2. This is giving us number of collisions per second. Okay, multiplying this n with area gives us number of collisions per second. So if I am multiplying that with this one, n into ab by 2, this is giving us a force. See carefully. Force means we are taking a rate of change of momentum with respect to time. Okay. So this is now directly number of collisions per second. Suppose this is now dn by dt, where n is number of collisions dN by dt is now number of collisions per second into change in momentum. That gives dP by dt. Remaining only calculation part, substitute here. In the place of F, it is small m V N A B. That is equal to 2 by 3 capital M G. Now substitute values in this. See what we get. Coming to values, capital M. In the place of a small m, it is given 0.01 kg small m. So I'm writing here 10 power minus 2 small m. We have to calculate. Number of collisions per second per unit area. N is given 100. N is 100. A value. We can say A value is 1. A value is 1 and B value 2. Let me cross check once. M value 10 power minus 2 kg. We have to calculate. N value 100, A value 1 and B value 2. Right. This is equal to 2 by 3. In the place of mass, it is 3 kg. G value 10. Okay. Remain just a calculation. 3 gets cancelled. 2 gets cancelled. 10 power minus 2, 100 gets cancelled. So V equal to 10 meter per second. So just taking that, the plate is now in equilibrium. So net torque equal to 0. Okay.